Hello class, welcome to Unit 2, Lesson 3. Today we're going to look at the midpoint and distance formulas, and then we're also going to use those formulas to find the area of a polygon and also show that a triangle is a right triangle. So the first thing we're going to do is look at a little example. It says, given 2 points, -4, -1, and 6, 3, find the distance between the points and find the middle of the segment. So what we're going to do is let's just sketch this out and think about how we could find the distance. So we have -4, -1, and then I would have 6, 3, and -4, -1. And we want to find the distance between those two. So right now I'm like, not a perfect distance or not a nice distance where I could just go ahead and count it out. So what I'm going to do is I'm going to draw a line from here so I can visually see my distance. I'm going to say, well, what could I do? Because this is not, you can't count out this length. I could go ahead and I could draw in this side and this side, okay? And then I could count this out, and I see I have a right triangle, so then I could use the Pythagorean Theorem, which is a squared plus b squared equals c squared. And when we do this, our goal is to find this length here, or the distance, so I'm going to call it d, okay? So we don't know that side. Okay, but I could count this out. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a distance of 10. And here I have 1, 2, 3, 4. Okay, so there's my distance on both sides. So I would have 10 squared plus 4 squared is equal to d squared. And remember, d has to be the c value because it has to be your hypotenuse, which is across from your right angle. So then we would have 100 plus 16 equals d squared. So I have 116 is equal to d squared, but I need to solve for d. So in order to solve for d, I would take the square root on both sides. So my distance is equal to the square root of 116. I would want to simplify this if possible. Exactly, so looking for perfect squares. So my first perfect square I would try is this 116 divisible by 4, and it is 4 times 29, and 29 is a prime number, so that means doesn't reduce any further. And then the square root of 4 is 2. So the distance is equal to 2 square root of 29, and that would be in units. All right, so if you ever needed to, you could always plot these 2 points, and you could actually draw out the 2 other sides. Could I have went up here and over here? Yes, it would have been the same triangle lengths, so you would have still gotten D. The other way that you can do it is the distance formula. If I didn't want to draw this, okay, do you guys agree this is my y-axis? So in order to get 4, really what we're doing is you're taking 3 minus my other y value, -1, which gives me 4. Okay, then you plug it into your distance formula, or sorry, your Pythagorean theorem, and you square it. Then the way I can go ahead and get 10 without having to actually draw it and count it out, I could do my x values, because this is my x-axis. I would do 6 minus -4, which gives me 10. Okay, so there is a formula, and we're going to look at it in a second, but that's where those numbers come from. It's finding the distance between these two. 3 minus -1 gives me how far the y's change, and then the same thing with my x's. Then we're also asked to find the middle of the segment. Okay, so I might look at this and say, is there like a nice little point that kind of looks like it here? Well, this might be it. Looks like it's kind of the middle. And the one way you could check is we're going to go up to 1, 2, 3, 4. If I go up 2 and over 4, is it the same? Yes. So this is my middle. And so my midpoint here, or the middle of my segment, would be 1, 1. That's not a 1. 1, 1. The way you can find the midpoint is basically by taking the average of 2 values. Okay, so I want to find the middle, so think about finding the average of something. You add the 2 numbers up and you divide by the number of numbers. So I would take my x's, 6 plus -4, and then there's only 2 numbers, so I divide by 2. That's going to give you your x value. Then I do the same thing with my y's. 3 plus -1 divided by 2, and that's going to get me my midpoint. 6 plus -4 is 2. 2 divided by 2 is 1. -3 plus a -1 is 2. 2 divided by 2 gives me 1, which is exactly what we had here. Okay. So my midpoint and distance formulas we have listed here. So we kind of talked about this, but distance, take the two x values, subtract it and square it, Pythagorean theorem. And then your y value, subtract it and square it. Once again, the square comes from the Pythagorean theorem. And then the square root. That was our last step we had to do to get the distance by itself. So once again, coming from the Pythagorean theorem. Then your midpoint formula, just always think average. You're finding the average of the x values. Add them up and divide by the number of numbers, which is 2. Okay, so there's distance and midpoint formulas. I would definitely write them down and I would definitely know them for your upcoming quiz. Example 1. It says plot the points, find the distance between the points, and then find the midpoint of the segment that joins them. Okay, we can plot them and we can see what this looks like. It is not necessary to plot them, but if you visually like to do that, then you can. So let's plot them. So we have -3, 6. And then I would have 11, 8. I think I'm on the right one there. There you go. And we're trying to find this distance here. So then you could count out and make a triangle. I'm just going to go ahead and use the distance formula. So B, the distance is equal to the square root of x2 minus x1. So 11 minus a -3 squared plus 8 minus 6 squared. This gives me 14. And so I have 14 squared, so distance is equal to 14 squared plus 8 minus 2 is 6. 8 minus 6 is 2. 2 squared is 4. So 4 squared. I already squared it. Let's back this up. My bad. 11 minus -3 is 14 squared plus 2 squared. So then I would say, well, 14 squared is 196. Plus 4, so I have the square root of this. And this gives me the square root of 200. Once again, we need to reduce this. So I would say, what's my perfect square in 200? There should be one that you see right away. 100 times 2. Square root of 100 is 10. And we cannot take the square root of 2 perfectly. So my distance is 10 square root of 2. And you could tack on units. So that's for part B. Then C, we're going to go ahead and find the midpoint. So we take the two x values, add them together, and divide by 2. So I have -3 plus 11 divided by 2. 6 plus 8 and divide by 2. So this gives me 8 over 2 and 14 over 2. So I would have 4, 7, and that would be my midpoint. And if I were to graph 4, 7 on here, does it look like it's the middle? I would say it does. So there you go. Oop, they got off a little bit. All right, that is example 1. Then we're going to go ahead and we're going to move on to area of formulas. Okay, so we're going to find the area of rectangles, triangles, and parallelograms. Okay, so remember a rectangle, some properties to know if it is a rectangle. They're all 4 right angles. And this side and this side are congruent, and then the opposite sides over here are congruent. And then usually we say, well, this is our length and this is our width, and so our area is to multiply them. Triangles. Remember, the area of a triangle is base, and then your height always has to be meeting at a 90-degree angle. It's 1/2 base times height. If you have an obtuse triangle, remember obtuse means your angle here is bigger than 90 degrees, your height is going to be outside of your triangle. So this would be your height. Okay, so base times height divided by 2. And then lastly, our parallelogram, remember that's basically your rectangle. If you take one corner and push it to the side, tilt it. Ooh, that's not a very good one. So since it's a rectangle, that looks bad. Let's fix that. There we go. It's a little better. So it's our rectangle push, so that means that this side and this side are still congruent, and this are still congruent. And the way you find the area of a parallelogram is your base times your height, which you find on the outside. So basically the area of a parallelogram is very similar to a rectangle, and here's why. Do you see if I take and I cut this triangle here and I were to move it over here, I would go back to having a rectangle. So that is the area of our parallelogram. Okay. Example 2 says draw the parallelogram, then find its area. So I plot my points. negative 4, 2. Then I would have 3, 2. So 3 to the right and up 2. So I have A and B. And then C is 5, 4. And negative 2, 4. C, D. And if I go ahead and connect everything, I will see that I have a parallelogram. The nice thing about this is I know that the area of a parallelogram is base times height. So I can actually, looking at this, I could count this distance out. If I couldn't count it out, we would need to go ahead and use the distance formula. But I can, so let's count out what my base is. 1, 2, 3, 4, 5, 6, 7. So it's a distance of 7. And then my height. I'm going to have to go ahead and extend here and draw this down. This is my height here, which is a distance of 2. So to find the area, it is 7 times 2. And so our area is equal to 14. And the way we label unit, or area, sorry, is units squared. So there is example 2. Example 3. Draw the triangle, then find its area. So we have A is negative 3, negative 3. B is 5, negative 3. And C is negative 4, 4. Okay, then we go ahead and connect them. And then remember that the area of a triangle is 1/2 base times height. Okay, so area equals 1/2 base times height. So I need to find the base, which I can actually count out. It's a nice straight line. So 1, 2, 3, 4, 5, 6, 7, 8. So I have that the base is 8. And then I need to go ahead and find this distance right here, because that would be the height of my triangle. This would be my height. Got to come down that right degree angle. So 1, 2, 3, 4, 5, 6, 7. So I have that the height is 7. So my equation is 1/2 times 8 times 7. So 1/2 of 8 is 4. 4 times 7 is 28. And then my label would be units squared. Once again, if you did not see that A and B were a nice straight line, you could just count out the distance. You could use the distance formula. So if you wanted to set it up, the distance would be B is 5, negative 3, and A is negative 3, negative 3. So distance is equal to the x values subtracted. So 5 minus a negative 3 squared plus negative 3 minus negative 3 squared. So this part actually gives us 0. And this would give us plus 3, so 8. 8 squared 64, so it's the square root of 64, which is equal to 8, which we found was our base. So you could do it that way, or you can draw it and you can find, and you can just count it out. All right, the last type of problem that we're going to go ahead and look at is proving that something is a right triangle. Okay, so if a triangle is right, then the square of the hypotenuse equals the sum of the square of the legs. So basically, if we've known that it's a right triangle, then we can use the Pythagorean theorem. Okay, now the converse of the Pythagorean theorem is if the square of the hypotenuse equals the sum of the square of the legs in a triangle, then it is a right triangle. So if you plug the values into the Pythagorean theorem and it works out that they are equal to each other, then you can conclude that something is a right triangle. So what we're going to do is we have to prove that something is a right triangle. Okay, show. So this is when I say show. You're going to be like, well, I can look at it and see it. However, I'm asking you to show, and so in order to show, it's a proof. And you are proving me through math that every single side is equal to the value you find, and then when you plug it into the Pythagorean theorem, it works. Okay, so let's go ahead and start by just drawing out this triangle. So we have h is -3, -4. Then we have 3, -2. Then we have -5, 2. Then we go ahead and we're going to look at it. Drawing in our lines. Okay, at first glance I look at it and I completely agree with you. It looks like a right triangle, but it's asking me to show, so I actually have to show it. And I'm going to label my sides. We have H, I, and J. And I'm guessing that this is my right angle, okay? By looks of it, probably most likely, but I'm not 100% sure. So what I have to do is I have to find the distance or the length of each one of these legs of the triangle. And then I need to plug that into the Pythagorean theorem. So I have H, I'm just going to label my points. So what I'm going to do is I'm going to use the distance formula, and I am going to find the distance of each one of these sides. So I will find HI first. So the distance between that, it is -2 minus -4 squared plus, I did my y's first. It doesn't matter if you do x or y's first, but if you guys are, the formula is written with x's, so I'll write it that way. So we got, 3 minus -3 squared plus -2 minus -4 squared. So this is going to give us 6 squared, which is 36. -2 plus 4, so 2 squared, which gives us 4. So it's 36 plus 4, and I'm going to leave it as the square root of 40. No need to simplify these. Okay, I'll show you why in a little bit. It will simplify very, very nicely if you just leave it as the square root of whatever. So there's HI. I've done HI. I'm going to go ahead and do the other leg, the one I don't think is the hypotenuse. I'm pretty sure JI looks like the hypotenuse, so I'm going to do HJ. So we have -5 minus -3 squared plus 2 minus -4 squared. So -5 plus 3 is -2. A negative squared is always a positive, so 2 squared is 4. Plus 2 plus 4, so we have 6 squared, which is 36. 4 plus 36 is 40. So we have that this is the length of 40, square root of 40. This is the length of square root of 40. And now we move on to what I think is the hypotenuse, JI, and we're going to find the length of JI. So the distance of JI is going to be -5 minus 3 squared plus 2 minus -2 squared. So this is -8 squared, which is 64. This is 2 plus 2, which is 4. 4 squared is 16. And then we have this 64 plus 16, which is the square root of 80. So since square root of 80 is a bigger number than square root of 40, I'm going to go with that, assuming that this, by looks and by the number, because the hypotenuse has to be the longest, we're going to assume this is the hypotenuse. So in order to actually show it, okay, this is part A, by the way. In order to actually show it, I need to say, well, the Pythagorean theorem is true. HI squared plus HJ squared, does that equal the hypotenuse JI squared? And if it does, if this left-hand side equals the right-hand side, then I can say it is a right triangle. So HI squared, HI was the square root of 40. So we have square root of 40 squared plus HJ, square root of 40 squared, equals JI, square root of 80 squared. So I told you not to leave it, which is actually really nice because square root of 40 squared, cancel those, so I got 40, plus the square root and the square cancel, 40 plus 40. Does that equal 80? That is the question. Well, 80 equals 80, and so since this works out, I can write my conclusion. So my conclusion, you got to write all this out. Since hi squared plus hj squared equals ji squared, that's ji, triangle hij is a right triangle. I can conclude that. Okay. So in order to prove something, you have to go through all of those steps and you have to show your work to show me the length of each side, okay, finding it with the distance, then plugging it into the Pythagorean theorem and then writing your conclusion, okay. On your homework, there are 2 of these, okay, 33 and 34. So make sure you're writing out all those steps. I want to see everything written out. Then B, find its area, okay? Area of a triangle is 1/2 base times height. So if this is a right triangle, my base would be square root of 40, and then my height would be square root of 40. So area is equal to 1/2 square root of 40 times square root of 40. The square root of 40 times the square root of 40 is 40. Okay, if you type it in your calculator, you'll get it, but also you'd have 40 squared, the square root of 40 squared, which is 40. So I have 1/2 of 40, which is equal to 20. So my area of my triangle is 20 units squared. So that is it for the notes for today. Your homework. (8 through 16, 32 through 34, 33 and 34 are the 2 that I said were the proofs. So please make sure you are writing out all your work and showing that. And then I just want to quickly look, numbers 8 through 16. 8 through 16, it says part A, plot the points in a coordinate plane. You can plot them if you want to, and then use the count out the sides of the triangle. If you want to plot them, you can, but I don't need you to plot them. For 8 through 12 would be that way. You don't have to plot them, but you do have to find the distance and the midpoint. And then, so maybe I'll make a note. Numbers 8 through 12, part A optional. Must do part B and C. Must do parts B and C. Okay, so that's 8 through 12. Then you have 13, 14, 15, and 16. I would highly recommend numbers 13 through 16 graphing. It will make it easier. It's finding area ones. If you can find the area and you can just count out side lengths, it'll make it a lot quicker. And then 32. Number 32, you don't need a graph. It's already on the book for you. It just says find the area of the triangle, and they have a picture drawn for you. Okay, so there's 32, and then 33 and 34, 33 is graph for you, and 34 I'd probably graph as well. But 33 and 34 are the proofs. Make sure you're showing out all those steps. If you have any questions, please be sure to ask me. Otherwise, have a nice day, and I will talk to you later.